So welcome everybody to this latest video on 162 Maths. In this video we'll be looking at angles with a focus of angles in polygons and looking and going over some exam style questions. Now there will be a copy of the questions that we go through in this video in the description below for you to download and have an attempt at either before you're watching the video to go through the answers, or you can go through the questions while watching this video. So before we get started, let's just go over some key things that you need to revise. So the first thing is, remember, vocabulary is really important whenever you're dealing with shapes or angles. So regular means equal sides and equal interior angles, and that's a really important factor to look out for. Also know the difference between interior and exterior angles. Now one of the biggest misconceptions, biggest errors that a lot of students make is they kind of get confused with regards to what is an exterior angle. Now imagine this is a vertice of a polygon. Now someone would say that the interior angle of this is going to be this here. So that would be the interior angle because it's inside the shape. And therefore this would be the exterior angle. Well, actually the green one is correct, but the blue one is incorrect. And the reason for that is because the exterior angle and the interior angle make an angle of 180 degrees. So this actually, if you draw a straight line from the edge of the shape, then this here would be the exterior angle. And how you want to kind of remember it is, if I just quickly draw, let's say, a pentagon, then imagine it like a Catherine wheel. So what you're finding is that each of these little spikes is joining up, and this there would be your exterior angles, like so. Now the next one is that the total sum of angles in any polygon is basically the number of sides take away 2 multiplied by 180. Now I know this may be another formula for you to remember, but a much easier way of working out how many angles there are in any polygon, doesn't need to be regular. So let's just join this one up. Oh no, let's get rid of those 2 lines there. And let me join this one up, is if you pick a point, and what you then do is draw a line from that point to all the other points. And what you'll do is you will form triangles. Now each of those triangles is 180, and you will find that the number of triangles is always 2 less than the total number of sides, hence why we get to that formula. Now the next one is that know polygon names and the number of sides that they each have. Now I would say probably you don't need to go on Google and know what a 32-sided shape is. I would say that you only really need to go up to a 10-sided shape, which is a decagon. So 9-sided is a nonagon, 8-sided is an octagon, a 7-sided is a heptagon, 6 sides a hexagon, 5 sides a pentagon, 4 sides quadrilateral, and then 3 sides is a triangle. So know how many sides there are and their names. Also that all exterior angles all add up to 360, and you can work out the exterior angle by using the formula of 360 divided by the number of sides of that shape. Now another rule that you need to know is that the interior angle plus the exterior angle equals 180, as we've previously mentioned. And you also know how to work backwards. So for example, if I gave you the exterior angle of a shape and I said it was a regular shape and asked you to find out how many sides it has, you may have like a close-up of a shape, very, very similar to, let's say, this diagram here, where it isn't actually explicit or obvious how many sides that shape has got, but you should be able to tell me if I tell you what the exterior angle is, or the interior or the exterior angle is going to be, to tell me what sides that's going to be if it was a regular shape. Now there also may be links to circle theorems, which is more on the higher syllabus. So if you're doing foundation, then circle theorems may come up in terms of a small capacity, but not in all its entirety. And there are also, if there's algebra involved, so if angles are given as letters of x or sort of linear expressions, then there may be links with solving linear equations, or maybe even simultaneous equations. And also understand shape properties, so know about diagonals, know about parallel lines and perpendicular lines, etc. And the last thing is also look out for isosceles and equilateral triangles and know their properties. So for example, isosceles triangles, you've got 2 angles that are going to be the same and 2 sides are going to be the same. For an equilateral triangle, the interior angle is always going to be 60 degrees, and obviously all 3 sides are going to be the same. Now, before we get started on these example questions, just a reminder that you can download these questions for you to have an attempt at, to have a go at before watching this video, or you can have a go at these questions while watching this video. So let's get straight into question 1. So question 1 says that BCD is a straight line, triangle ABC is equilateral, and CE equals DE. And the question is asking us to work out the angle of X. Now with this, although there's several lines for me to show my working out, I can now get away with doing my working out on the diagram. So as we mentioned, that if ABC is an equilateral triangle, then it means that this angle here is going to be 60, this is going to be 60, and this is going to be 60. Now if triangle CDE is a isosceles triangle, then this angle here is going to be the same as this angle here. Now to work out what this angle here is going to be, I do 180 minus 28 divided by 2, and if I simply word that out, 180 minus 28 is 152, divide that by 2, and I get an answer of 76. So that angle there is 76, and so is this angle. Now from this I can then work out what X is, because it's all on a straight line. So here X equals 180 minus 60 minus 76, and if I quickly just simply word that out, I get an answer of 44 degrees. And that's what I will put here. Then with question B, it says Amber is working out the size of an interior angle of a regular octagon. Her method is the interior angle equals 360 divided by 8. Is her method correct? Well, the answer is going to be no, and the reason for that is because she has used the interior angle instead of the exterior angle. Now you could also work what that is. So 360 divided by 8 gives me 45. But again, if I wanted to work out how many triangles there are, well, again, it's going to be 6 times 180 equals 1080. And then divide that by 8, and I get 135 degrees. So using this I get 45 degrees, and that's wrong. And again, you could even say that 360 divided by 8 is 45, and that's an acute angle. And as you can see, the interior angle is going to be obtuse, so you know it's going to be wrong there. Or you could actually give what the correct angle is going to be, but definitely the answer is going to be no. Her method is incorrect. Now work it out with question 2. It says, what is the size of an exterior angle of a regular decagon? So again, knowing that a decagon has got 10 sides, so it's going to be 360 divided by 10, which equals 36. So it's my second answer. Then with question 3, it says the sum of angles in a quadrilateral is 360 degrees. For example, in a rectangle, 4 times 90 is 360. Zach writes 5 times 90 equals 450 degrees. So the sum of angles in any pentagon must be 450. Is he correct? So again, if we just do a little sketch of a 5-sided shape and draw a dot at one point and then draw a line going to each of the points, you can see here that in a pentagon, it's going to be 3 times 180, and 3 times 180 is 540. So is that correct? No, he's not. So we'll tick no, and the reason for it is because the total sum of angles in a pentagon is 3 times 180, not 5 times 90. And again, another reason why is because the interior angles of a pentagon are not 90 degrees. So again, there's several reasons which you could give there, but I would say that's probably the first one that comes into my mind. So question 4 says, which of these shapes has the most sides? So a hexagon has 6, an octagon has 8, a rhombus has 4, and a trapezium has 4. So the correct answer there is an octagon. Then with question 5, it says that a regular polygon has an exterior angle of 20 degrees. Work out the number of sides of the polygon. So here we've got the exterior angle equals 360 divided by the number of sides. So here what we've got is, we know we've got 20 equals 360 divided by x. So then if I then do 360 divided by 20, that should give me the number of sides. So 360 divided by 20 gives me an answer of 18. So there are 18 sides in this polygon. Then moving on to question 6, it says two congruent regular polygons are joined together. Work out the number of sides of each of the polygons. Now for this, what I want to do is, if I draw a line splitting this up, I get this as being 30 degrees and this being 30 degrees. So that means that the exterior angle of the polygon equals 30 degrees. So just like using what we did in the previous question, so here we're going to do 360 divided by 30 equals the number of sides. And then it's going to be 36 divided by 3, which gives me an answer of 12. So it's going to be 12 sides. Then with question 7, it says the exterior angle of a regular polygon is 45 degrees. Circle the name of the regular polygon. So again, 360 divided by 45 will tell me how many sides that there are. And 360 divided by 45 is 8. So I'm looking at which of these is an 8-sided shape, and it's going to be an octagon. So looking at question 8, it says that A, B, B, C, C, D and D, E are 4 sides of a regular decagon. And the question is asking us to work out the size of angle W. So from this, what we need to recognize is that, well, first of all, let's work out what the total sum of angles in a decagon is. So the total angles, or sum of angles, I should say, is going to be 180 times 8. And if I do 180 times 8, I get an answer of 1440 degrees. Now if I then divide that by 10, I get 144 degrees. So that means that this angle here is 144, this angle here is 144, and this angle here is 144. Now this shape of ABCDE is a pentagon, so all the sides need to add up to the total sum of angles in a pentagon. So the total sum of angles in a pentagon is going to be 3 times 180, which is 540. So here the equation I've then got is 2w plus 144 plus 144 plus 144 all add up to 540. So 144 times 3 is 432. So if I just then have a bit more room, I've got 2w plus 432 equals 540. So 2w equals 540 minus 432, which equals 108. And so w equals half of that, which is 54 degrees. Then moving on to question 9, it says the diagram shows 2 regular hexagons with the baselines extended, and the question is asking us to work out the values of x and y. So here what we've got to do is, we know that the 2 angles are add up to the respective angles. So here we've got that y plus 4x equals 120 and y minus x equals 60. So as you can see by writing this out, this now resembles a simultaneous equation. So if I multiply this first equation by, well actually I don't need to multiply it by 4 because I could just notice that the y's are the same. So if I take away the 2 equations, I end up with 5x equals, and that's going to be 60, so x equals 12. And then from this, if I pick any of the 2 equations, so let's just go for this angle here and this angle here, that we then know, so if I just put a little box around this, so we then know that y plus 4x equals 120. Well, if x equals 12, then 4 times 12 is going to be 48, And so y equals 120 minus 48, and 120 minus 48 gives me 72. So y equals 72 degrees. So in the answers, I can then put 12 degrees and 72 degrees. Then for question 10, it says the hexagon has two lines of symmetry. Work out the size of angle y. So here again, this angle here is going to be 152. This angle here is going to be 152, and this angle here is going to be 152, and this angle is going to be y. Now, let me just explain why it mentions that there's two lines of symmetry without crossing out the question. So the reason, let's try that again. Now, the reason for it saying that it's got two lines of symmetry is recognizing that the angles are the same. So the two lines of symmetry here, which basically implies that this angle here is the same as this angle here, and this angle here is going to be the same as that angle there. So working this out, we've got a hexagon, so the total sum of angles in a hexagon is going to be 4 times 180, and 4 times 180 is 720. So then what I've got is I've got 2y plus 152 plus 152 plus 152 plus 152 all need to add up to 720. Now 152 times 4 is 608, so 2y plus 608 equals 720. So 2y equals 720 minus 608, which is 112. And so y equals, and that's going to be 56. Now moving on to question 11, it says that a regular pentagon is drawn inside a regular octagon as shown, and the question is asking us to work out the angle of P. Now for angle P, so angle P is going to be equal to the interior angle of the octagon minus the interior angle of the pentagon. And so that's what I need to work out first. Now in terms of the interior angle of an octagon, well, the int angle of the octagon is going to be 180 times 6 divided by 8, because there are 8 sides. So 6 triangles, 8 sides. And if I do 180 times 6 divided by 8, I get that an interior angle is going to be 135. And then the interior angle of the pentagon is going to be 180 times 3 over 5. So 180 times 3 is 540, divided by 5 equals 108. So that means then P equals 135 minus 108. So 135 minus 108 equals 27 degrees. Now moving on to question 12, it says that this pentagon has a vertical line of symmetry. The ratio of angles B, C and D are in the ratio of 6 to 3 to 4, and the question is asking us to work out the size of angle B. Now whenever it mentions the fact that there's a vertical line of symmetry, is basically indication that some angles are going to be equal to each other. Now if we've got a vertical line of symmetry, then this is really the only vertical line of symmetry we could have, which basically means that this angle A is going to be the same as angle C, and angle E is going to be the same as angle D. So from this, what we can know is that the total sum of angles in a pentagon, and we should know this with the amount of questions that we've done. So total sum, I should write not total angles, let's get rid of that. So total sum of angles in a pentagon is equal to 540. Now if I write down all the angles, so I've got A, B, or no, A and B, C, D and E, and I write down these sort of ratio parts. So C is 3, D is 4, and B is 6. Well, A and C are the same, so that means that if C is 3, then A must be 3. And D and E are the same, so if D is 4, then E must be 4. So now what I've got is I've got the number of parts of each angle, and if I add up the total number of parts, I've got 3 plus 6 plus 3 plus 4 plus 4, so that's going to give me 20. So I've got 20 parts equals 540, so therefore one part is going to equal 540 divided by 20, which is 27 degrees. So angle B equals 6 parts. So then the angle is going to be 6 times 27, and 6 times 27 is 162. And that's where we finish.